notice I have a few different sizes here. Okay, this is in comparison to my finger. So this one looks like a small bead, but I have lots of smaller sizes. I want 0.1 grams, and you can see that this one is about 4 times too much. So I'm going to need to use the smaller pieces of copper in order to get to approximately 0.1 grams. Make sure that when you take your mass, that both doors of the balance are closed so that you get an accurate mass. Otherwise, the air currents will cause fluctuations and give you an improper mass. Once your copper has dissolved in the nitric acid, your solution may look green. Now, the copper nitrate should be blue, but you'll notice that there's a bit of a orangish brown gas above our solution. So what that indicates is that there is still some of that gas dissolved in here. We're going to leave the beaker in the hood warming, but not boiling, as long as we still see a green color or a brown gas. Now, if you start to remove the beaker from the hood and you are hit with a painful or overwhelmingly pungent odor as you take it back to your desk, that means that there is still some of the dinitrogen tetraoxide, which does not have the brown color but is equally as toxic. So you want to return it to the hood and let it warm just a little bit more so that we can get rid of those gases. Notice the difference in color between the solution on the right and the solution on the left. The green solution on the right still needs to heat and be stirred, while the solution on the left is nearly ready to move on to the next step. Now that our solution is sky blue, we want to transfer it to the volumetric flask. Make sure that you place a funnel in the volumetric flask. For quantitative transfer, we need to rinse out the beaker. We want to get every little bit of copper that is still in here. You can tell that there's still copper because there's still light blue there. We won't be able to see every last bit of copper, so what we want to do is rinse, swirl, and transfer 2 or 3 times just to make sure that we've gotten all of the copper from the solution. If you used your stirring rod to stir the mixture while it was on the hot plate, you'll want to make sure that you rinse down the stirring rod as well in order to get any copper that is attached to the stirring rod. Once your flask is about half full with the sky blue solution and some deionized water, you're going to add some ammonia. Ammonia can be very painful if it gets into your eyes and into your nose, and it's toxic. So this step should be done in the hood. You want to make sure you don't add so much of the deionized water that there's not enough for the ammonia. So make sure that you're nowhere near the neck of the flask when you're at this step. This should be added through a funnel, and what you will notice, sometimes it will get stuck part way, so lift up the funnel and that'll let it drip, but you'll notice a dramatic color change. Now you can see that the color is darker on top than it is on bottom, but if we swirl this around, then the color becomes all very dark blue. So the reason that this happens is because copper, when it is dissolved just in water, is surrounded only by the water and by 6 water molecules in particular. For reasons we're not going to go into, when a metal ion is surrounded by 6 molecules, the energy changes that happen when light is absorbed aren't really allowed, and so it doesn't absorb much energy, and colors tend to be very pale. When the ammonia is added, the ammonia surrounds each of the copper ions, and only 4 of them go around the copper. This is a tetrahedral arrangement, much like the carbon and hydrogens in the methane molecule, and this does allow for the light changes, so it absorbs very, very intensely. So the copper attached to the water and the copper attached to the nitrogen are called metal complexes, or complex metal ions. At this point, you want to add more deionized water until you're going to get to the line that marks the measurement. So on here, it's right here. We'll take a closer look at that in a minute. But you're going to want to add just to the bottom of the neck. If you try to get to the line itself, you're very likely to overshoot. So we don't want to do that. Remember that water may gather in the funnel and take a minute to drip. So if you pour a little in, don't keep pouring. Wait for it to go down through the funnel to see how far it is filled. So right now I'm so close to the neck, I don't want to pour anymore. I'm going to switch to using the squirt bottle in order to spray in a little bit at a time. When you are close to the line, what you want to do is make sure that you're looking at the line straight on. Right now I can see that that line looks like a very elongated oval. What I want to do is shift what I'm looking at so that my eyes make those to appear straight across and I don't really see an oval at all. Remember that as you add the water, you want the meniscus to sit on the line, so the bottom of the meniscus is where the line is. Right now my meniscus is just below the line, so I'm going to add one drop at a time until I see it come just above the meniscus. Be careful as you add your drops that it does not get caught in the neck of the flask, because that won't change the level, but it will add to the total volume as you mix after you do this part. All right, so that looks like the meniscus is sitting right on the line, and so that tells me I have a very precise measurement of the volume of this flask. You'll notice that not all of this solution is blue. The liquid that is in the neck is not the same concentration as the liquid at the bottom. So every time I fill a volumetric flask, once I get it to the line, I want to use a secure stopper. If you don't have a glass stopper designed for the flask, ask your instructor for a cork or rubber stopper. Which one you will use will depend on the contents of your flask. You don't want it to react with either the rubber or the cork. You're going to take the flask and invert it, wait for the bubbles to go to the other end, and go back and forth at least 10 times in order to ensure everything is well mixed. At this point, surely you'll have some of the solution that is caught in the neck or in the cap, but that's okay because we already know that the total volume is the appropriate total volume. You're going to be using several pieces of glassware in this experiment. You're also going to need to be paying attention to what happens to the concentration when you transfer that solution from one place to another. We want to start with a clean and dry beaker. If the beaker's wet, when I transfer the solution, I no longer know the concentration. So we want to make sure that this is really dry and really clean when we transfer it. We also are going to have several solutions here, so we want to make sure that each of them is labeled. If you don't have a second flask to use to prepare your next standard, you can reuse this one. We want to make sure that none of the copper remains, so you're going to rinse it several times with deionized water. When you do that, don't pour the remnants into this flask. Again, the water would change the concentration. Instead, bring over a waste beaker. Don't throw your solutions down the drain because copper can be harmful in large amounts in the environment, so we want to make sure that it is treated before we dispose of it. Don't forget to rinse off the stopper that goes into your flask. And that way we don't get any copper from that either. Set it aside so that it can dry before you're ready for this step where you are mixing the next solution. As you rinse down the flask, turn the flask so that all of the walls are covered. Swirl the liquid and dump it into your waste. Do this several times, also leaning the flask to the side so that you make sure that your distilled or deionized water goes down the side of the flask and catches all of the droplets that have copper. Now, do we need this flask to be dry when we use it? We don't. And the reason for that is that we're going to be adding deionized water to it anyway. So it's okay if it has deionized water. We just want to make sure that we've removed all of the copper. To make standard solution number 2, we're going to use a pipette. Now, with the pipette, depending on whether somebody has used it before in a previous class or not, there might be liquid droplets in it, as you can see there are in this one. I don't want that to get into my solution. So what I want to do is get out as much of the excess as I can, but that may not get rid of all of the droplets that are in there. So the next thing that we're going to do, that may not get rid of all the droplets. So the next thing that we're going to do is we're going to pull a small amount. Now we don't want to fill the larger part of the bulb because we need 25 milliliters of the solution to make the standard. So we're going to aim to just fill this bottom part here. With that, we're going to use it to rinse out the pipette and then transfer it into the waste beaker. If you're using the black pipettes, you can push on the S to suction until you're just at the bottom there. If you're using the red pipettes, you need to be careful and control what you're doing. Now, we don't want anything to go back into this solution because we know this concentration pretty well. So before you do anything else, move the pipette over the waste container. Tilt the pipette to the side and replace the bulb with your finger. Because the pipette drains slowly, you should still have plenty of solution in here. Allow the solution to get into the bulb. You might need to remove your thumb just a little bit to let more in and slosh it back and forth while you turn so that you get all of the little droplets. Then allow it to drain into the waste beaker. Repeat this process 2 or 3 times so that you make sure that any droplets that remain are the same concentration as your standard solution. Each time, make sure that you don't empty into the standard solution, but anytime anything leaves the pipette, it is going into the waste container. And again, only a few milliliters because you need at least 25 to move on to the next step. Now that you have used the fill, dump, fill method in order to ensure that you are not changing the concentration of your solution, your pipette should contain droplets of the blue copper that is the same concentration as your standard solution. Now we're going to use the pipette bulb again, this time allowing it to fill all the way to the line at the top. If you find that the solution is no longer filling, you may have 2 issues. First, pick up the pipette from the bottom. Sometimes if it's resting on the bottom of the beaker, that can prevent the liquid from going in. If your bulb is completely inflated again, then you're going to need to squeeze it. So if you are using the red bulb, you need to replace the pipette with your thumb, squeeze the bulb, and then put it back on top. If you're using the black bulb, the process is a little more complicated. If we push the E on the side arm, that's going to let air in and let our solution out. If we do the S, it's going to allow the bulb to expand, pulling in solution, but it can't expand anymore. So what we need to do is hold on to the A, squeeze that while we squeeze the bulb. When you do this, the bulb should stay squeezed in and the liquid in the solution. You may need to have somebody help you with that as you do this process. In my case, I've gotten a bubble in here, so what I'm going to do is allow some of this to drain back into the original solution. Remember, this is all the same concentration. To do that, I'll squeeze the E, allowing it to drain until the bubble is gone, and then the S for suction, making sure that the end of the pipette stays below the level of the liquid, and I will aim for the line at the top. Just like with the volumetric flask, You want to make sure that you are looking at it straight on so it doesn't look like an oval. You will probably find that you overshoot. This is okay. With the red bulbs, you're going to have to go back and forth between using your thumb and using the pipette bulbs to release some of the solution and pull it back up until it's at the right spot. With the black bulbs, you have a little more control by pushing on the E until it is in the right level. But if you overshoot, you do have the possibility of using the S to pull more solution in. You should have 4 standard solutions of known concentrations. You may only have 2 cuvettes, so you're going to have to use the fill, dump, fill method in order to make sure that we're not changing the concentration of the solutions for the next part where you're doing the readings. To begin using the colorimeter, you are going to push the power button, which is right here, and you should see one of the lights with a number of it glowing. So right now I have this one glowing, and that's just showing me which bulb is glowing on the inside. What you'll notice once you've turned it on is that if you open this chamber, you will have a square opening. That square opening is for a cuvette. And so the cuvette can slide into that opening. What we want you to do before you get started is take a look at what color appears inside there. Now, right now, we can't really tell the color. It's going from one side to the other. So we're going to stick in a little piece of paper to see what color is visible. Depending on what works best for you, you may want to try and insert the paper from the back opening so your hand isn't in the way. With this piece of paper in here, if I hit the cal button for calibrate, it's going to briefly flash the color of light that is going to shine through, and you should see it on the paper. As you change the wavelength, so this one was 430 nanometers, just at the edge of what we can see. Pushing this button will move it to a different wavelength, and I'll see a different color, and I can do that for all the different wavelengths. You should also see a flashing light here. It'll flash again in a minute. That's telling you what it is connected to. So what you're going to want to do is make sure that this is connected to whatever device you're going to be recording on. So this might be your tablet, it might be a tablet that you've borrowed from us, or it might be your phone.
When you open Graphical Analysis, you should see a screen that looks like this. Click on the Data Sensor Collection in the upper left-hand side. Below Proximity Connect, you should see a list of the different colorimeters. The one I'm using ends with the number D68, so I'll choose that one. We only really need to collect the numbers here because we'll be graphing in Excel. In the upper right-hand corner, click the rectangular boxes, and you can turn on the data table. You can change it to just one graph, as one graph will always show. Notice our graph currently says time on the x-axis. We don't want that, we want events, so click on the bottom left-hand corner where it says mode. Change time-based to event-based. You can make the units grams per liters, molarity, or leave it blank. Click on the average sensor reading for 10 seconds in order to assure we have a good reading over a period of time. Alternatively, you can leave it on entry-based. With each reading, you'll need to enter in the concentration that you have calculated.
Based on your understanding of visible light, you should know that we can see in the low 400 nanometers up to 700 or so nanometers, depending on the person. Also, we know that since we are trying to look at how much light is absorbed by a blue solution, we don't want to use the blue light because the blue light is clearly passing through. So you'll select a color that will be absorbed by that blue solution. What you want to do is calibrate your colorimeter. In order to do that, you need to have a solution that is very similar but with no color. So we're going to use deionized water. Most of the square cuvettes will have two sides that have lines on it, the front and the back on this one, and two sides that are very smooth. This is designed so that you keep your fingers on the lined side so that you don't have fingerprints that are messing with the absorption of the color. So make sure you are always holding the side that is either frosted or has lines on it. You're going to fill it about 2/3 to 3/4 full with deionized water. The exact amount isn't important, you just need it high enough that the light can see it. But you'll notice that I have bubbles in here. Those bubbles are going to affect how much is absorbed. So what you want to do is flick your cuvette while holding it. You might want to put a lid on it until the bubbles are out of the way. Using a lid will help to keep the solution from spilling, but it's not absolutely necessary for the process. If you have any smudges, you can use a chem wipe, which is a chemistry version of a tissue, to clean off the surface. Make sure you're not using a regular tissue because those sometimes have lotions in them where this will just be plain. Another way that you can get bubbles out of your cuvette is to gently tap it on the counter and the bubbles should rise to the surface. All right, now that we have our water, we're going to place it into the colorimeter. I'm holding it on the frosted sides, but the light is passing from here to here. So that means the non-frosted sides, the clearest sides, need to be facing this wall and this wall. The frosted sides or the lined sides are going to be facing me and away from me. So I have the lines facing me, and that way the light can pass through the clearest side this way. I don't want any ambient light from the room, so I'm going to close this before I make my measurement.
On the colorimeter, now press the Cal button. You should see the red light flashing for a few seconds. When it is done flashing, it is calibrated at this wavelength. You don't need to calibrate in between each reading. The one calibration for each wavelength is fine. To take your reading, click the button Collect at the top. Keep should now be highlighted. Before you hit Keep, make sure your next sample is ready and the door is closed. Then hit Keep, and it should average over 10 seconds. So you'll have to wait with the door closed while this screen is showing. If you chose not to make a value for each sample, it will simply number them. So starting with sample number 1, we'll have the standard number 1 be the appropriate one. If you have chosen to have an entry with each of your measurements, you can either type in the number of the standard or you can type in the concentration. If you type in the concentration, it'll give you a sense of what your graph is going to look like in the end. Here I have also put in the measurement of the calibration where I've had the deionized water at 0 absorbance and 0 concentration. You'll repeat this process for each of your standards. It doesn't need to go in order because as you type in the number of the standard or the concentration, it will put it in order on the graph. Because I have put in the concentrations here, I can see what my final graph is apt to look like. And you can see it's mostly a straight line, though the measurement for the first standard does seem to be a tiny bit off. If you want to see what the trend line is going to look like, click on the small graph icon in the lower left-hand corner of the graph. It will pop up a menu giving you several options. Select Apply Curve Fit and linear should pop up, and then select Apply. You should see the equation appear on the screen with the values for m, the slope, and b, the intercept, shown underneath, along with the r value. Under Graph Options, you should be able to add a title to the graph. It's not necessary for today's graph because the one you'll turn in will be on Excel, but in future labs you may end up using this option for showing your graphs. You can minimize the equations by clicking on the small dash next to the X. Click Stop so that when you do your unknown measurements, you won't have to enter a concentration. You won't know the concentration for these. You will click Collect again and Keep for each sample. It will give you the option to append your data or make a new set. You want to make a new set. Click Mode again, make sure you're on event-based, and make sure that you click Selected Events. Once you have collected the data for each of your samples, including your two unknowns, make sure that you write down the data that is in the data table so that you can move this over to Excel. Excel will allow you more options for determining how your fit works and give you an easier time in displaying your graph.